We've been introduced to ethers before, and we're just going to look at them in a little bit more detail here. So we want to remember that ethers, the functional group for ether is an oxygen that is singly bonded to two carbon-containing entities. Now, if we're looking at the naming, sometimes ethers are named by the groups that are attached to that oxygen. So, for example, dimethyl ether, two methyls bonded to that oxygen. Ethyl methyl ether. Notice that those alkyl groups are put in alphabetical order. And diethyl ether. These are some common ethers. There are cyclic ethers, and they tend to be referred to by their common name. And here are a few: ethylene oxide, tetrahydrofuran, also known as THF, and 1,4-dioxane. Ethers can also be named by referring to the OR group as an alkoxy group. So, for example, if we look at this compound here where the main group is ethanol, what is attached to it is an ethoxy group. So this would be called 2-ethoxyethanol. The one carbon is where the hydroxyl group, and the 2 is where the ethoxy group is. And even on a benzene ring, this would be O-methoxyphenyl, where the R group here bonded to the O is methyl, so this would be methoxy. And dimethoxyethane. So for example, we have ethane here and 2 methoxy groups bonded to it. You're not going to be responsible for naming, so we're not going to go over any of the examples, but you may come across these names in future chemistry or biology courses, and so it's good to know what functional groups they refer to. So let's look at some of the properties of ethers. Ethers, of course, do not have a hydrogen directly bonded to the oxygen, so therefore they do not form hydrogen bonds with each other. And however, they are polar. That oxygen, that ether oxygen is polar, so ethers have higher boiling points than alkanes of similar molar mass, but definitely lower boiling points than alcohols, which can hydrogen bond. Now, that oxygen in the ether is polar, and low molar mass ethers are soluble in water. And ethers are really good solvents. They're easy to evaporate or boil off, and sometimes organic chemists need to do reactions with a solvent that doesn't have an OH group like alcohols or water. So ethers are good solvents under those circumstances because that OH group can be really reactive, and if you want to avoid that, ethers are good choices. Ethers are alkane-like in many properties. For example, they don't react with acids or bases, so good solvent if you want to have a reaction with acid or base and not have the solvent interact with it. They are very, very flammable. They have high vapor pressures, and a really dangerous property of ethers, if they stand in the presence of oxygen, many ethers will form explosive peroxides, compounds that contain this oxygen-oxygen single bond, which is extremely unstable. So they have to be handled with care. You don't want to store them for very long. If you ever buy them, you don't want to keep them around because they can form these very explosive peroxides. And just a fun fact, diethyl ether was a anesthetic until the 1940s. It acts very quickly, but it has a long recovery time, and often it can make people nauseous. And also another fun fact is ethers are found throughout the plant and animal kingdoms in naturally occurring molecules. Some are even used in perfume. So for example, if we look at anethol, it's a flavoring agent that's found in anise and fennel. Here's our ether group right here. There's 2 other functional groups, are aromatic as well as an alkene. And then this juvenile hormone is an insect hormone found in the silkworm moth. So here's our ether functionality group. And it's also fun to identify other functional groups. So here we have our alkene double bond, another alkene double bond, and then an ester functionality. This carbonyl carbon singly bonded to an oxygen, which is then bonded to another alkyl group.